listeners. This is Yashash. I'm the instructor for your Arduino programming course. In the previous episode, you have learned how to download and install Arduino IDE. In this episode, you'll be learning about hardware details of Arduino board. Before we actually start, we'll see what's the cost to use Arduino boards. The flexibility of the Arduino board is enormous, so that one can do anything that he or she imagines. This board can be connected very easily to different modules such as obstacle sensors, presence detectors, fire sensors, GSM and GPS modules, and this goes on. The main function of the Arduino board is to control electronic items through reading inputs and changing it into outputs, because this board works like a tool. This board is also used to make different electronics projects in field of electronics, electricals, robotics, and so on. In this episode, I would like to expound the hardware details of Arduino Uno because it's one of the best boards for beginners to get started. There are other boards too in the market that are available. They are Nano, Micro, Mega, Due, and Leonardo. You can choose any, but I recommend you to go with Uno, which is this. So overviewing the hardware details, at the top we have the brain of the board, which is the microcontroller, that is Atmega 328P. It's a high performance, low power consumption 8-bit AVR microcontroller developed by Atmel. And the memory details are, it comes with 32 kilobytes of flash memory, in which 0.5 kilobytes is occupied by the bootloader. It has 2 kilobytes of static RAM and 1 kilobytes of EPROM. The Arduino Uno board can be powered via the USB connection or with the external power supply. The power source is selected automatically. The board can operate on an external supply from 6 to 20 volts. If supplied with less than 7 volt, causes the 5 volt pin to supply less than 5 volts and board may become unstable. If using more than 12 volts, the voltage regulator may override and damage the board. The recommended range is 7 to 12 volts. Then comes the VIN pin. To input the voltage to the Arduino board when it is using external power source, you can supply voltage through this pin. The voltage that you can supply here is between 7 to 12 volts. Then the 5 volt pin. This pin outputs the regulated 5 volt from the regulator on the board. The board can be supplied with the power either from the DC power jack or from the USB connector or the VIN pin of the board. Supplying voltage via the 5 volt or 3.3 volt pins bypasses the regulator and can damage your board. I don't advise it. And 3.3 volt. A 3.3 volt supply generated by the onboard regulator, in which the maximum current that comes out of this pin is 50 milliampere. You can use this pin for connecting small devices such as Bluetooth modules, because there are certain voltage limitations for some devices. And then GND, which is ground, for common ground connections. IORF. This pin on the Arduino board provides a voltage reference with which the microcontroller operates. For example, when you configure some external shields with respect to your Arduino, it can read the IORF pin voltage and select the appropriate power source or enable voltage translators on the output to work with the 5 volt or 3.3 volt. To be more precise, here is an example. The input or output logic level of the Uno is 5 volt, but the Bluetooth that I oftenly use is of 3.3 volt. If the voltage level is different between these two boards, it will be as if two persons speaking two different languages, which is very difficult to understand. I hope that you got the idea. And the Uno comes with 14 digital pins, which can be used for input as well as for outputs. They can operate at 5 volts. Each pin can provide or receive 20 milliamperes at recommended operating conditions, and has an internal pull-up resistors which is disconnected by default, which is of 20 to 50 kilo ohms. In the upcoming episodes, I'll teach you how to invoke these resistors with the help of coding. A maximum of 40 milliampere is the value that must not be exceeded on any of the input or output pins to avoid the permanent damage to the microcontroller. Some of the digital pins come with the specialized function. For example, pin 0 and 1 for serial communication, in which RX stands for reception and TX for transmission. Then the pin 2 and 3 for external interrupts. These pins can be configured to trigger an output on a low value, a rising or a falling edge, or change in a value. Some of the digital pins come with the partial analog characteristics. For outputting the data, they are 3, 5, 6, 9, 10, and 11. With 8-bit accuracy, they are called PWM pins, which stands for pulse width modulation. These pins can be differentiated by the wave dash symbol and the pin 10, 11, 12, and 13 for SPI communications. SPI stands for Serial Peripheral Interface. And the board comes with built-in LED, which is internally connected to the pin 13 of the Arduino. When there is a high value at this pin, the LED turns on, and at low remains off. The Uno has 6 analog pins labeled from A0 to A5, each of which provides 10 bits of resolution. By default, they measure from ground to 5 volts, though it is possible to change the upper end of their range using AREF pin, stands for analog reference, which means reference voltage for analog inputs. And there is a reset button, which while pressed brings this line low to reset the microcontroller without erasing the code that you have dumped. Then comes the crystal oscillator. Every Arduino has an onboard clock source, typically running at 8 MHz or 16 MHz of frequency, but the Arduino Uno is clocked at 16 MHz frequency by default. This is fair enough to know about the hardware details, and these parameters also replicates to the other boards as well, with some feature change. If this was informative, then a sub to the channel would be stupendous. Thank you.